Hello students, in our today's video, capsule part 3, we are going to study about hard capsule shells. So let's begin. Here you can see the structure of hard gelatin capsule, right? Hard gelatin capsule is a solid dosage form that is also referred to as a dry filled capsule or two-piece capsule. You can see here our hard gelatin capsule consists of two parts. The first one is body and the second one is cap. The body also consists of shoulder, then locking ring, then mouth diameter, air vent as well as a tapered ring, whereas cap may consist of dimple and hemispherical end, right? Also it has outer diameter of the ring which is and a chamfering ring. The diameter of body is comparatively or slightly less than that of cap, right? Moving further, now we'll be seeing how this cap and body are actually made. So this is the systematic representation of manufacturing of hard gelatin capsule. You can see here it includes of the step like that of dipping, followed by spinning, then drying. After drying, the next step involved is stripping, cutting and joining, right? So this is how basically our hard gelatin capsules are prepared. Then let us see these steps one by one in more depth. So this is the systematic representation of the various steps that are involved. So the first one, preparation of gelatin solution or also known as dipping solution. So a concentrated solution of gelatin is prepared by dissolving the gelatin in demineralized water which has been heated to 60 to 70 degrees Celsius in a jacketed pressure vessel. The solution contains 30 to 40% weight by weight of gelatin and is highly viscous, which causes bubbles as a result of air entrapment. The presence of these bubbles in final solution would yield capsule of inconsistent weight and would also become problematic during capsule filling and upon storage. Therefore, to remove these air bubbles, a vacuum is applied to the solution. The duration of this process vary with batch size. Then the next step is dip coating the gelatin solution on the metal pins, also known as molds, right? So also sometimes this step is referred as dipping. So here a pair of stainless steel pins are dipped into a dipping solution to simultaneously form the cap as well as the bodies. The dipping solution is maintained at a temperature of about 50 degrees Celsius in a heated jacketed dipping pan. Then the next step is rotation of dip coated pins, also referred as spinning. Following adsorption of gelatin solution on the surface of pin, the bar containing the pin is removed and rotated several times to evenly distribute the solution around the pin. Correct gelatin distribution is very critical for uniform and precise capsule wall thickness and dome strength. Step number 4 is drying of gelatin coated pins. So once the gelatin is evenly distributed on the mold, the blast of cold air is used to set the gelatin on the mold. At this point the gelatin is dried and the pin are then passed through several drying stages to achieve a target moisture content. Then the next step is stripping and trimming. So once the drying process comes to its end, the pin plate enter the table section of the machine. Here the capsules are divided into two equal or we can say roughly equal size, which are then stripped of the pins. After stripping from the pin, the machine then trims the shell into the required length. Once the trimming comes to its end, as per the requirement, the machine automatically joins the two halves into blocks. The joint blocks are then shoved into the conveyor belt, which in turn transfer them out to the container. This can also be explained as in stripping a series of bronze jaw strips the cap and body portion of the capsule from the pin is termed as stripping, and Then the stripped cap and body portion are trimmed into the required length by stationary knives, and that is called as what we can trimming. And after trimming to right length, the cap and body portion are joined and ejected from machine. Then the next step included is joining and trimmed capsule shell. So once trimmed, the two halves already as seen before, that is the body and cap, are joined to the pre-closed position using a pre-locked mechanism. At this point, printing is done if needed. Then the next step is printing. After formation, the capsule shell can be printed to improve identification. Printing can be achieved using one or two colors, then containing information such as product name or code number, manufacturer's name or logo, right? Then printing reduces the risk of product confusion by the numerous handlers and users of the product, including manufacturer, pharmacists, nurses, doctors, etc. Sometimes printing is followed, done next to printing is polishing. Okay, so sometime it is done, sometime not. So polishing can be done. So for polishing, either pan polishing can be done, or cloth dusting or brushing, whichever as per the norms can be utilized. Then next step is testing. So once the manufacturing and printing of capsule comes to its end, capsules are transferred to testing cells. So this is the point where one ensures that the quality of capsules are good that have been manufactured, and for that the capsule undergoes various tests and quality checks which ensure that they are of good quality and they have required shelf life. Then the next and last step is packaging. So after completion of the test, capsules move to packaging stage where they are packed conventionally. This conventional packing make handling of the capsules easier. It also ensures longer life of the capsule shell and ease of delivery as well. This is the entire process of capsule shell manufacturing. Then the next is ingredients used in hard gelatin capsule shell. So the various ingredients that are included in manufacturing of hard gelatin capsule shell include dye, plasticizers, then sugar, then edible colorants, then demineralized water, opacifiers, glycerin, etc. We have already seen this ingredients in detail in our previous video. Moving further, hard gelatin capsule size in the market. So in market, hard gelatin capsules are available in a standardized size. This image gives a detailed description about capsule size and uh, capacity that can be contained based on powder density as well as ml, right? So the first one is, if a size is 000, that is the largest capsule, it can accumulate around 615. If a powder is having a 0.45, that it is light, its density is comparatively low. For typical, that is for 0.70 powder density, it can accumulate up to 960, and if it is heavy, then it can accumulate up to 1370, and it can store volume. In terms of volume, it can store 1.37 ml, right? Then if capsule size is 00, then for light powder it can accommodate 430, for typical 665, for heavy 950, and for moisture 0.95. The last column is about logged length. So logged length is around 23.30. Then the next one is for size 0. For light density powder, it can accommodate around 305. Then the next one is for typical powders, it will be able to store around 475. This is in mgs. Then for heavy, it will be 680. For in terms of ml, it will be 0.68, and logged length is around 21.70. Then if capsule size is 1, you see the are keeping on decreasing, right? That is, capsule 5 is the smallest and 000 is the largest size capsule. So for size 1, for light it is 225, for typical it is 250, right? And for heavy powders it is around 500, and in terms of ml it is 0.50 that can be accommodated in that respective capsule, and log length is 19.45. If capsule size is 2, light density powder that can be accommodated is 165. For typical, having density of around 0.70 that can be accommodated is 260, and for heavy 370. In terms of ml 0.30, and log length is 18. Then for capsule size 3, for light powder it is 137, for typical 210, for heavy 300, and for a volume that can be accommodated is 0.30, and log length is around 15.90. Then the next one, for capsule size 4, powder having or which is light in nature, that can be 95, for typical 145, for heavy 210, and in terms of volume 0.21 ml can be accommodated, and log length is around 14.30. And last one, for capsule size 5, light powder that can be accommodated of density around 0.45 is 60. Then typical powder having density of around 0.70 that can be accommodated is 90. Then heavy having density of around 1 that can be accommodated is 130. In terms of ml it is 0.13, and log length is 11.10. So this gives a detailed description of the various gelatin capsule size that are available in market. Moving further. Okay, now let's talk about defects that can occur in hard gelatin capsule. The first defect can be related to that of shape, right? So if shape is not proper, the defects that can occur is dent, then mashed, short and long cap and body, then double cap and bend. So these are the various defects that are related to shape. Then the next defect that can occur is based on color. So it can be different color or discolor. The next defect is based on appearance. So there can be appearance of dirt, there can be appearance of foreign particles, there can be scrap, age, spilt, cracked, then telescoped and hole that can appear on the surface of the either body or cap of the capsule. Then the next defect is printing mark. So there can be either mark has been stated but there are no mark, or there are improper mark. So these are the defects that can be related to that of printing mark. So these are basic 4 important defects that can occur. I'll revise. The first one is shape, then color, then appearance, and then print mark. Then moving further, quality control of empty shell. The first test is identification test for capsules. So here boil 1 capsule shell with 25 ml of H2O, allow cooling and centrifuge. Then to 5 ml of supernatant liquid you can add 1 ml of tannic acid solution, and PPT is produced in each case. Then it is capsule. Then next one is microbial limit test. So this test is done to check any presence of microbes, especially bacteria, in capsule shell. So here what is done is crush the capsule and see the powder of shell under the microscope. Total microbial count for 1000 gram of capsule shell, 1 gram of capsule is free from E. coli and salmonella. Then the next test is loss on drying. So this test is done to check the moisture losing limit of capsule shell when kept in extreme condition. Then the next test is disintegration test for capsule. So this test provide to determine whether capsule disintegrate within the prescribed time when placed in liquid medium under the experimental condition. The next test for which empty shells are evaluated is average weight. So this test provides limit for I mean permissible variation in weight of individual capsule expressed in terms of the allowable deviations from the average weight of the sample. Then coming to next one, dimension of hard capsule. In dimension of hard capsule, that is empty shell, they are checked for any sort of defects that we have seen previously. Then coming is defect in hard gelatin capsule. So the defects that can occur in hard gelatin capsule other than those already seen may include shell surface are not smooth, then opacifier not proper, then empty capsule after the filling stage, that is already filling have been done, however still a capsule has remained or the capsule shell has remained empty. Then the foreign matter inside the capsule, capsule fitting not uniform after filling, then capsules are not of specified type, color variation and color non-uniformity of appearance may occur. Then the next one is surface spot and embedded particles on the capsules, and capsule may have cracks, breaks, pinhole or splits losing its integrity. So these are the various defects related to that of hard gelatin capsules. Then coming to last part of this presentation, that is storage of hard gelatin capsule. So hard gelatin capsule can be individually protected by enclosing in strip or blister packs. In the former one, that is in strip packaging, the unit are hermetically sealed in strip of aluminum foil or plastic film, whereas in later one, that is the strip packaging, one of the film encloses the unit, sorry, in blister one, one of the film encloses the unit is formed into blisters. Then an ideal foil or film for this pack should be, first of all, it should be heat stable, then impermeable to moisture, water vapor, air and odors, then enough strong for machine handling and reasonably easy for patient to tear and open. So this is all in our today's video. Thank you for watching till end.